So this is referred to as ice albedo feedback, where we have decreasing ice, decreasing albedo, and increased energy absorption by the system and increasing temperatures, whereas on the glaciation side we have increasing albedo, increasing glacier volume, decreasing temperatures, continued glacier buildup, and so on. But in this case we are looking at the positive feedback by the CO2 as well. So CO2 is also decreasing and increasing the cooling and the buildup of glaciers. CO2 is increasing in this phase and increasing the greenhouse effect and increasing the warming. So you can call it carbon cycle positive feedback as well. I had briefly mentioned the negative feedback on longer time scales. The main thing is to remember carbon dioxide has always been part of the story over all time scales. So one of the stories that hypothetically that has been argued is that as India moved from the south across the equator and crashed into the Asian plate and continues to push forward, the Himalayas arose. So here you are 70 million years ago, 50, and this is now, let's say, the current configuration. The Himalayas continue to rise by a centimeter or so, I think, per is it per year? I think so. So that buildup of the mountains exposed a lot of the sediments and other material, and before, when India was here, obviously the monsoonal circulation didn't exist, so you didn't have copious amounts of rain here, and building the mountains and pouring rains on top obviously increased weathering and drawdown of carbon, which is argued to be one of the reasons why the temperatures cooled after the meteorite crash, disappearance of the dinosaurs, and this warming here. And then you can see we've been in this cooling phase, so the global warming is actually happening in the background of this very long time, multi-million year cooling, and that cooling is presumably due to the Himalayas. So there have been tectonic movements all along the way, so you can see here the CO2 estimates associated with those. Obviously there are uncertainties associated with these estimates, as you can see with these error bars or standard deviations from various evidences like phytoplankton, stomata, nacolites, boron, liverworts, and so on, and so paleosols are old soils, and so on and so forth. So atmospheric concentration of carbon dioxide in parts per million by volume was as high as 1500 or maybe even 2000 at some point. The so-called Cretaceous hothouse happened before that, where you had some of the warmest temperatures, and then CO2 has been drawn down and we reached the 280 ppm, which was approximately the value at the end of the last ice age, maybe even into the beginning of the industrial revolution, since the end of the last ice age. So CO2 here has again did a negative feedback by being drawn down because of the mountain building and causing cooling. Well, you can call it a positive feedback, but it's a cooling effect, whereas in the global warming situation we have a warming effect. Okay, so this is interesting to, of course, extend to geologic timescales as well, going back to 100 million years ago. It was Pangea divided into distinct land masses. So you can see North America, South America, Africa is sitting here, Europe and Asia, Australia, and so on. 200 million years ago it was all together as Pangea, and the continents are still moving. In fact, when Alfred Wegener first proposed this I think in the 1920s, by looking at the shape of South America and Africa, he imagined that they fit together at some point, they must have been together. People laughed him out of the room, and I think pretty much till he died it was not confirmed that actually tectonics is real. Nonetheless, present day we look like this. There have been various openings of the isthmuses and the Drake Passage and mountain building and so on and so forth. As the continents keep moving, in 100 million years, this is how you would look. The continents would converge and so on and so forth. So there are paleo techniques using which these are geolocated with time. So you need to time them and you need to locate them latitudinally. But the main thing about carbon cycle here is that depending on how the continents are distributed, the global circulation will be different, global mean temperature will be different, rainfall distribution, desert distributions will be different, and so on. And that would mean weathering rates would be different, carbon cycle would be different, and so on and so forth. And one always wonders what favors the glaciations at the poles. For example, Antarctica started glaciating only about 35 million years ago. So obviously there are details about how the ice albedo feedbacks work, how carbon cycle feeds back into that, and so on and so forth. So I will leave it here and we will discuss briefly the future global carbon cycle just to get set for the rest of the course, because currently we are worried about emissions, its impact on global warming and global temperature increase and other effects, and we want to see how the future of carbon cycle may look. Right? We have been talking about the past, the positive feedback and the negative feedbacks and so on. So let's do that in the next podcast.